In this section, we will learn the relationship between the zeros and the coefficients of the polynomial. Okay, now let us start with linear polynomials, right? We know that a linear polynomial is a polynomial of degree 1, right? And it can be expressed as ax plus b, where a is not equal to 0, p of x equals to ax plus b. So, the 0 of px is the value of x when p of x equal to 0. So what is p of x equal to 0? Ax plus b equal to 0. So this gives us x equals to minus of b by a. Now if we compare from here, what is b? B over here is the constant term, right? And what is a? A is the coefficient of x, right? So here this is the relationship between the 0 of the polynomial and the coefficients of the polynomial, that here the 0 is equal to 0 of px is equal to minus of constant term upon coefficient of x. Okay. Now let us come to the quadratic polynomials. Now we know that a quadratic polynomial is a polynomial of degree 2. Right. Now let us understand with the help of examples first, and then we will generalize. Okay. Now let p of x equals to 2x square minus 8x plus 6. Okay. Now we will try to make factors of this polynomial. How we will do is that we will split the middle term. We will split this. How? We have already studied in class 9 how to split the term. So we will multiply the coefficient of x square and the constant term. So 2 into 6 we get 12. So how are we going to uh, have the multiples of 12 such that their addition gives us minus 8. So 12, see 12 I can write as 3 into 4, 12 I can write as 6 into 2. So if we add 3 and 4 we do not get 8. If we add 6 and 2 we get 8. Okay, so 6 and 2, but here it is not 8, here it is minus 8. So both of these should be minus 6 and minus 2, so that if even we multiply we get 12. Okay, so that is how we are going to split the middle term. So we can write this as 2x squared minus 2x minus 6x plus 6. Now if we consider these two terms, if what is common among these two terms, we have 2x. Okay, so what is left if we take out 2x from here? X. And what is left here? 1. Okay, now from here if we take these two terms, if we take minus 6 common, we get, what do we get over here in this term? X. And what do we get over here? Because we had plus here, so we will have minus here. So eventually if we multiply this term and this term, we get plus 6. Okay, so now let us combine these terms. So 6 here, if this is one term, this is one term, what is common among these two terms? X minus 1 is common, and what are we left behind? 2x minus 6. So I can write this as, if we take out 2 common from this, 2 is common, we can say x minus 3. Okay, so now eventually we had to find the 0 of the polynomial px. So px का 0 तब आएगा when px equals to 0, right? So what is px equal to 0? If this term is equal to 0, so this term is 0 if either this term is equal to 0 or this term equal to 0. So if either x minus 1 equal to 0 or x minus 3 equal to 0. So that is either, from here what do we get? X equal to 1 or x equal to 3. So 1 and 3 are the zeros of the polynomial p of x. Alright. Now you please note one thing over here. If we find the sum of these zeros, let us see. 1 plus 3, what do we say? It is 4, and 4 can be written as minus of minus 8 by 2. So I can say, if we consider this initial polynomial, from here what I can say, what is minus 8? Minus 8 is the coefficient of x, and what is 2? It is the coefficient of x square, right? And if we find the product of the zeros, 1 into 3, what do we get? 3. So I can write this as 6 by 2. So what is 6 here? 6 is the constant term upon what is 2? 2 is the coefficient of x square. Okay, now let's consider another example. Now let p of x equal to 3x square plus 5x minus 2. Now we will try to factorize this polynomial, and how are we going to do it? We are going to split the middle term. Okay, what is the multiplication of 3 into minus 2? It is minus 6, and how are we going to split minus 6? We can say that 6 into 1 or 6 into minus 1 is minus 6, and we can say 5 equals to 6 minus 1. So let's come over here. We can say, we can write this as 5x can be written as 6x minus x minus 2. Okay, now let us consider these two terms. What do we get? We have 3x common over here. We are left with only 1x. Okay, and 2. Okay, now from these two terms, what is common? Minus 1 is common, and we have x plus 2. Okay, now from this term and this term, what is common? X plus 2 is common, so what is left behind? 3x minus 1. So we can find the 0 of the polynomial p of x equal to 3x square plus 5x minus 2 when p of x equal to 0, and p of x equal to 0 if this term equal to 0. Now this term is equal to 0 if either this term equal to 0 or this term equal to 0. X plus 2 equal to 0 or 3x minus 1 equal to 0. That is either, from here what do we get? X equal to minus 2, or from here x equals to 1 by 3. So minus 2 and 1 by 3 are the zeros of the polynomial p of x. Now let us consider the sum of these two zeros. Okay, what is the sum? Minus 2 plus 1 by 3. So I can say, I can write this as minus 5 by 3. Okay, now let us compare with the initial equation, the initial polynomial, sorry. So I can say minus of, this can be written as minus of coefficient, what is 5? 5 is the coefficient of x, what is 3? 3 is the coefficient of x square, right? And if we find the product of the two zeros, what do we get? We get minus 2 by 3, which I can write as, what is minus 2 over here? Here it is the constant term upon what is 3? 3 is the coefficient of x square. So from both examples, we have found out that the sum is equal to, the sum of the zeros is equal to minus of coefficient of x upon coefficient of x square, and the product of the zeros is equal to constant term upon coefficient of x square. Now let us try to generalize. Okay, if alpha and beta are the zeros of a quadratic polynomial p of x equal to ax square plus bx plus c, where a is not equal to 0, then if alpha and beta are the 0, then we can say x minus alpha and x minus beta are the factors of p of x, right? So what I can say, ax square plus bx plus c, I can write this as k into x minus alpha, x minus beta, where k is a constant term, right? I can write this as this. Okay, so if we multiply these terms, what do we get? X square minus x beta minus x alpha plus alpha beta, right? So this can be written as k into x square minus alpha plus beta x plus alpha beta. Now I can write this as kx square minus k alpha plus beta x plus k alpha beta. Now, if we compare the coefficient of x square x and the constant term from here and from here, what do we get? We get a equals to, if we compare coefficient of x square, a equals to k. Let's compare the coefficient of x. We get b equals to minus k alpha plus beta, right? And if we compare the constant term, we get c equals to k alpha beta. So what is alpha plus beta? I can say alpha plus beta equals to b upon minus k, which I can say minus b upon k, which now we know that k is equal to a. So minus b by a. What is the product of the two roots? Alpha beta. From here what we can say, alpha beta equals to c by k, and we know the value of k equals to a. So this is c by a. So for any quadratic equation we can say that the sum of the zeros is equal to minus of b by a, which is equal to minus of coefficient of, what is this, x upon coefficient of x square. And what is the product of the two roots? It is c by a, which is equals to constant term upon coefficient of x square. So this is the relationship between the zeros and the coefficients of the polynomial for quadratic equations. Now let us understand about the cubic polynomials, right? Now we know that a cubic polynomial is a polynomial of degree 3. Now let us first understand with the help of an example. Let p of x equal to 2x cube minus 5x square minus 14x plus 8. Now you don't have to find the zeros of for cubic polynomials. So I'll just write straight away that x equals to 4 minus 2 and half are the zeros of the polynomial p of x. Okay, and you can cross verify this. How? If you put x equal to 4 in this polynomial, it would come out to be 0. And similarly for minus 2 and 1 by 2, that is p of 4, p of minus 2 and p of half are equal to 0. Okay, now note that what is the sum of the zeros? The sum of zeros is equal to 4 plus minus 2 plus half. So if we calculate, we get 5 by 2, which is equals to what? Minus of minus 5 by 2. So I can write this as minus of, what is this? It is here coefficient of x square upon coefficient of, 2 is the coefficient of x cube, coefficient of x cube. Okay, now what is the product of the zeros? Product of the zeros is 4 into minus 2 into half, which is equals to minus 4, which I can write as minus of 8 by 2, which can be, what is 8 here? We can say minus of constant term upon coefficient of x cube. Okay, there is one more thing to note over here, that is the sum of the product of two zeros at a time, that is 4 into minus 2 plus minus 2 into half plus 4 into half, right? What is the value over here? We get minus 8 minus 1 plus 2, which is equals to minus 7. So minus 7 is what? Minus of 14 by 2, which is, what is 14 over here? Minus 14. This is coefficient of x upon, what is 2? 2 is coefficient of x cube. So now let us generalize this. So now for a cubic polynomial, if alpha, beta and gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, where a is not equal to 0, then alpha plus beta plus gamma equals to minus b by a, which is equals to minus of coefficient of x square upon coefficient of x cube. Now alpha beta plus beta gamma plus gamma alpha is c by a, which is equals to coefficient of x upon coefficient of x cube, and alpha beta gamma is equals to minus of d by a, which is equals to the constant term upon the coefficient of x cube. So in the case of cubic polynomial, this is the relationship between the zeros and the coefficients of the polynomial. So if you like the video, please subscribe to the channel and share it with your friends. If you have any queries, share them down in the comment section below.